Hello everyone, welcome to my channel on data analytics. I am your host Professor Rage Uday Kiran. In this video, we are going to learn about object-oriented programming concepts, briefly called OOPS concepts. The outline of this video is as follows. First, we discuss the history of object-oriented programming. Then, we look at the differences between the structured and object-oriented programming. Finally, we talk about classes and objects. Coming to the history, we know that the topmost prize in the world is Nobel Prize given to 6 different fields. For computer science, we do not have Nobel Prize award. The key question is, what is the topmost prize given to the scientists in the field of computer science? The Turing Award is given based on the mathematician called Alan Turing. He is the person who invented Turing machine. There is a movie called Imitation Game, which is based on the hero Alan Turing. Okay, if you haven't watched it, please watch it. The second question I want to ask is, are the today's modern computers equivalent to Turing machines? Yes or no? Please stop this video. If you do not know, please search in the web and try to find out. This information is very useful for all of you. Now let us look at the timeline. Theory of computation or Turing machines were investigated prominently until 1930s. So around 1930s, it was well established that lambda calculus and Turing machines are convertible most of the time. Then, in a decade, low level programming languages came into existence. The problem with the low level languages is difficulty in coding. So, in the next decade, somewhat high level programming languages such as Fortran and COBOL came into existence. And the limitation of Fortran and COBOL are they are difficult to implement algorithms. So in 1960, decade later, ALGOL, algorithm language, the first structural language programming came into existence. And then in 1960, the basic ALGOL programming language gave birth to the C language. This is how we have come to the structural programming language C. For the time being, let us ignore the introduction of C language because the fundamentals of structured languages has already been investigated in 1960s. Now let us look at the alternative timeline. When people are developing C, what was happening parallelly is in 1966, Alan Kay first came up with the concept called object oriented programming. He came with this concept because he wanted to perform computation in a distributed environment. So when Alan came up with the concept of object oriented programming, the focus was how to do message passing between the machines and encapsulation and dynamic binding. So only these three were the main focus when Allen was designing the object-oriented programming. So if we look down, the timeline looks like this. In 1960, these concepts for structural programming language came into existence. In 1966, the concepts of OOPS were introduced. He developed a software called Sketchbook based on the OOPS concepts. A year later, he came up with the software called Simula. And over the period of time, the OOPS concepts emerged and in being incorporated into Java, C++, and so on. So this is how the OOPS concepts emerged over a period of time. Now the key question comes is, when we had structural languages, why do we need object oriented programming languages? What benefit do they provide over structural programming languages? The main purpose of developing a software is to capture a reality, that is any application that you want to capture. This is called small world or universe of discourse in the set theory. So according to universe of discourse, anything can be divided into sets and functions. A set is a collection of elements, whereas a function takes a set and converts it into another set. So this is called universe of discourse, and any real world application can be captured. So this is how the mathematics initially started capturing the real world. So when we came up with the programming languages, we also wanted to capture the reality using sets and functions. So the higher programming languages such as Fortran, COBOL, and C, what they did is, for sets, they call elements or attributes. For them, they had a separate declaration, and for functions, they had another one. So, elements and procedures or elements or functions were separate. These functions were working on the elements. So they try to mimic exactly how the mathematics used to work. But the problem is, when we try to bring those mathematical concepts into the programming environment, the security of the attributes is getting corrupted. Okay. So this was the problem. Means the original data may get easily corrupted. To tackle the data corruption problem in the procedural languages, object-oriented programming language came into existence. The main focus of object-oriented programming languages is encapsulation. So, in this object-oriented, we have a class. In that class, data and procedures exist in unison, means they stay within that class. So this ensures that data will not get corrupted, and also there won't be any unauthorized access to the data. So this is the reason why object-oriented programming languages became popular. Let us try to understand it with an example. If you are familiar with C, we know that in C, any function can call any other function and so on, which is not an advisable approach. So, in object-oriented programming, what we have is, we have a class which we call it template. From this class, we can create multiple objects, and these objects can be used for computational purposes. So this is the advantage. So let us see this figure in detail. The concept is called encapsulation. So in a programming language, we know that we have some fields or variables and we have methods. If you are familiar with C, we know that fields and methods can be directly accessible in C. This causes data corruption and unauthorized access issues. In object-oriented programming, fields and methods are encapsulated within the class. Any interaction with this class can happen only via objects. So this is the advantage of object-oriented programming. Now, coming to the main concepts of object-oriented programming, the fundamental ones in OOPS concepts are class and objects. We will now look at what is a class, what is an object, and how these objects get created. Talking about the class, in object-oriented programming, reality is captured using classes and objects. Basically, a class acts like a template with properties and behavior. For example, we can think student is a class, okay, with a particular student ID as an object of this class. This student has some properties like height, weight, gender. Similarly, behavior, hardworking, running, and so on. So overall, if you want to keep in mind what is a class, please keep this figure in mind. Basically, a class has attributes and behavior. Now, what are the properties of the class? Class is not a real world entity. In contrast, object is a real world entity. Okay. So if someone thinks a class is a real world entity, please tell that class is not a real world entity. Since class is not a real world entity, we even do not create a memory for it in the programming languages. So basically, a class contains data members, methods, constructor, nested class, and interface. So we can see the basic structure of the elements in a class. And here I have provided an example. So this is how a class looks like. A class simply contains attributes and functions. We create objects for the class, and these objects represent the real world. Thus, when we are creating objects, the programming language, any programming language, whether it is Java, Python, or any other OOPS based programming language, allocates memory for the object. So we have a class here. When we create the object of this class, this object not only inherits states and behaviors, it will also inherit the unique identifier of that object, because we can create several objects for the class. So let us see a very good example of it. So here we are creating a class called dog. This dog has the attributes breed, age, and color. Similarly, the dog has the behavior bark, sleep, and eat. When we try to create objects for this class dog, then we have the object identifier, then the attributes of the dog, and the behaviors of the dog. So this is the object. Now what we can do is we can create instances. For example, dog 1, dog 2, dog 3, dog 4 with various attribute values and behaviors. So this is the overall process of how we create objects of a class. A sample example of the code is given on the right side. Please pause this video and check it. Until now, we have looked at what is a class, what is an object, and how we can create objects out of a class. Now, the key question that comes in mind is, if we have a class, how are the objects created and how the compiler movement happens in the class? To understand the compiler movement, let us take an example of a class bicycle. Okay, this bicycle has the attributes, and then we have behavior or functions. If you observe a particular function, bicycle, you can see that the name of this function is same as the class name, and there is no return type mentioned here. So this type of special functions are called constructors. In the previous videos, we have already discussed that these constructors are the entry points for the Java instances. Means the Java process enters into the class from this constructor. Now, let us create objects for this class using another program. So in this program, we have public static void main, where we are creating two objects of this bicycle class, and we try to change the functions of those objects. So if we have a Java compiler, the key question is how to compile and execute these two programs. That is Java bicycle.java class and bicycle.demo.java class. So we have two Java files. How to execute? Let us take the class file, bicycle class. Okay. The Java compiler once enters into this class, it founds there is no static main function, okay, main function to enter. So Java compiler will not enter into this class file. Next, the Java compiler will check the class bicycle demo. This class has public static void main function. So this Java class will enter into this function and enters and reads the first line, that is bicycle, bike one, new bicycle. So after reading this file, the compiler creates the object bike one and visits the class bicycle. Here the object bike one will be created and its values cadence, speed and gear are initialized. Next, it will enter into the entry point and tries to set these values. Once these values are set, it will exit and comes to the next line. Here there is one more bike. So it will again goes back to the class bicycle, creates one more object and comes back. Later, it will read the next line, bike 1, speed up 10. So bike 1 object goes to this function speed up, increases the speed by 10 and then comes here to the next line. The next line, print stats will be print. Bike 1's print stats will be print and then bike 2 will be done. So in the similar way, line by line, the steps will be performed. So that is how the compiler will behave. Thank you very much for listening to the video. Here I am providing a good material on how the step-by-step compilation happens in a Java program. If you are interested, please check this link. For more information, please subscribe to our channel. Please press the like button if you liked our work.